Hi, I'm Anas from Oxylabs, and in this video, we'll show you how to build a robust and dynamic web scraper using Selenium and Python. You'll be able to use it to scrape complex, dynamic websites and completely automate your data collection flow. If you're looking to scrape data from a website, you've likely heard of tools like Beautiful Soup and Requests. They're well-known Python libraries that can retrieve and extract information from a static website. However, most modern websites are dynamic, meaning they use JavaScript to load additional content on the page after it's initially opened. In this case, retrieving the HTML of the page isn't enough, as it's likely the case that a lot of the data will be either not loaded yet or just a click away. Luckily, there is a perfect solution for that. Selenium, a browser automation tool, is perfect for tackling this issue. It's designed to open a browser from a Python script and load the page as you'd see it in Chrome or Safari. It makes it possible to interact with the page like any human would, by clicking buttons, filling out forms, or waiting for content to load. This makes it an essential tool for scraping, as most sites nowadays are dynamic. While other tools like Playwright exist, Selenium remains a popular and robust tool for browser automation. For this tutorial, you'll need to have Python installed on your system. We'll also be using VS Code as the code editor. Open up a fresh VS Code window and launch a new terminal. Type in these commands to create a virtual environment and install the Selenium library. Now we can create a file called main.py and start writing our script. Modern Selenium includes everything within its package, so there's no need to install a browser driver separately. To open up a browser, it's enough to import the WebDriver, declare a driver variable, and have it navigate to a website as follows. Let's use the Oxylabs scraping sandbox for this part of the tutorial. We'll also add a wait time to see if it works correctly. Let's run the script to see what it looks like. As you can see, the script opened up the page as requested. Before going any further, we should investigate what the page looks like under the hood so we know how to select the data we need from the page's HTML. Let's open up the sandbox in a regular browser. If you right-click on any element and click Inspect, you'll open up the DevTools of your browser. With this, you can identify the specific tags and class names for each element on the page. Let's say we want to scrape the title and the price of every product within the sandbox. As you can see by hovering over the elements, each title is wrapped in an h4 tag with a class title, and the prices are inside a div container with the class price wrapper. We'll use this information for scraping later on. Now we can begin writing the main logic for the scraping part. For the scraper to work as expected, we'll need to make the browser wait for the elements to load until we can locate them. It's possible to do this with Selenium by using the WebDriverWait component and providing the CSS selector we want. It can look something like this. By now, the script will have loaded all the content we need to extract the data. We can use the driver itself to extract data from the page using the CSS selectors we located before. Let's use the .product card selector to get each product, then loop over each one and extract the results. We can append the results to a separate list and print it out afterwards, like this. After running the script a few times, it's often unnecessary to see Selenium open up the browser as a separate window. To avoid it, we can enable headless mode, which is essentially just opening a browser instance without it being visible. We can add this import and this option to the driver to do just that. Let's run the script to see the results. As you can see, we've successfully extracted all the information we need from the website. However, The sandbox example is relatively simple and doesn't require a lot of browser manipulation to effectively retrieve the data from the HTML. What we learn now is the basics of opening a website with Selenium and retrieving data for it. Let's take a look at some more advanced use cases where simple HTML parsing starts to be insufficient. Imagine we want to scrape recipes from a page like allrecipes.com. It may be possible to scrape most of the data you see when you open the site, but you might also want to retrieve multiple pages of search results, for example. Some pages might also offer infinite scrolling, which requires the browser to imitate a scroll gesture to load up the data. Let's see how to tackle these issues in our Python script example. Let's replace the sandbox URL with an all recipes page, where you'd search for chicken recipes. The page contains a list of page numbers you can use to navigate results. Let's see how we can use Selenium to access these pages, in case we want to scrape a larger number of recipes in one go. This time, let's declare the WebDriverWait object separately, like this. Next, let's handle a case that might be relevant for many websites, which is clicking the Accept Cookie prompt at the beginning. We can do it by finding the button's ID, waiting for it to be clickable, and clicking with the click method. With that settled, we can now declare a for loop where we'll click on the next page button each time. We'll do 2 pages for this example, but you can adjust this number for your needs. Let's find the next page button and add another wait method to make sure it's present in the page before attempting to click it. As the button might not be in view, we'll run this command to scroll the page until the button is visible. After that, it's enough to run another script to click the button and add a small timeout after that, so that the browser can catch up. If you disable headless mode and run the script now, you can see how, after the browser is launched, it navigates through the steps we covered gracefully. However, do keep in mind that the structure of the website might change, which might lead to unexpected behavior within the script. This can be mitigated by catching exceptions inside the code or just allowing the script to break intentionally, so it's clear that the page isn't compatible with your scraper. Also, some pages might have a stricter anti-bot policy, which would block the scraper from accessing any content via blocking or a CAPTCHA mechanism. There are ways to go around this, but it's important to note that scraping should be handled ethically and responsibly. You should always mind the robots.txt file on the page if it has one. Try to be careful not to overload the website with your requests, and cache when possible. To conclude, we've looked at how to use Selenium for scraping data from a simple website by using CSS selectors. We've also looked at how to manipulate a website with Selenium to access more hard-to-reach data points. Selenium still has much more functionality within it to look into, such as screenshots and cookie management, which is worth looking into if it fits your use case. If you'd like to dive deeper into proxies, be sure to check out our Proxies Explained playlist or explore more in-depth guides on our blog. And if you ever need help choosing the right solution, reach out to us at support@oxylabs.io. Thanks for watching. If you found this helpful, don't forget to like the video, subscribe to the channel, and turn on notifications for more content like this. Till next time.